Canada's Technology Triangle.net user group, and I see a lot of new faces, so this is really exciting. My name is Curelet-Balan, and I am one of the lead organizers of this user group. We run our sessions 2 times a month, usually once on the second Wednesday of the month and once on the fourth Wednesday of the month. So welcome to tonight's session. First, I want to start off by thanking our Postseason sponsors, North Sail Software. So Natalie is here from North Sail. Thank you for sponsoring the full stream of this session for the season, as well as Microsoft. Without them, we wouldn't have the room, we wouldn't have the snacks. So I just want to give them a round of applause before we start. And along with myself as one of the organizers, we do have other organizers that help run the group, and you can reach out to any of us anytime. Dan actually does have Twitter now, so I'm going to update this with his Twitter handle. We just signed him up recently. Congratulations, Dan. Also, today's Dan's 30th birthday, so you can have some cake in the back and some snacks back there after. There's Ken Sanarelli and Arlen Nugara, who also help run this user group. And if you love to tweet, definitely use our hashtags for tonight's session, our user group acronym, as well as Azure Functions and Xamarin. And at the end of the meetup, please go onto the meetup site and rate the meetup. Leave a star rating. Let us know what you like, what you don't like, things you'd like to see in upcoming meetups. We definitely love to get that feedback because we do tailor our sessions based on what the user group members are saying that they want to see us bring to the sessions. And coming up, so Prairie DevCon, it's a conference in Winnipeg. It's going to be held in June of this year, June 5th and 6th. Definitely very cost-effective conference to attend, but very action-packed. It's not geared just to .NET or Microsoft. It is very technology agnostic. So there's a wide range of sessions and technologies that are covered at this session, packed 2 days. It's definitely worth looking into, asking your employers if you can get some sponsorship to go out there and spend a couple of days in Winnipeg. He's actually hosting it in June, so it should be spring weather by then. And Global Azure Bootcamp in Waterloo. Arlen and Ken are running this on Saturday, April 21st. It's at the Cambridge Chamber of Commerce. You have to sign up on the Eventbrite page. I believe it's just like a $5 nominal fee just to make sure that they have cover for catering for the number of people that are coming. And they are also running the Waterloo Azure user group, which this is the kickoff session for it, this full day workshop. And then from here on in, we'll probably see some regular sessions coming up from them. And then HackerNest. How many people here have been to a HackerNest? A couple people, a few people? Yeah, I expect. And there's a lot of young guys in this room. I know you go to the HackerNest socials. They're a lot of fun. So in May, they're going to be, where are they going? eSolutions, May 14th. So that should be a fun night. And Girl Geek Dinners, Waterloo Region. April 26th is the next session if you're interested in finding your mentorship fit, Natalie and me. Because there's no other women in the room today, thanks. And without further ado, welcome to Mark Arteaga from Redbit Development. I'm going to let him take over from here to talk about serverless computing with Azure Functions and Xamarin.
Azure Functions and Xamarin. So, very quickly, I'm going to go through a little bit about who I am. For some reason, people ask me, want to know what I do, who I am. I'm going to go a quick overview of Xamarin. How many people have used Xamarin before? How many are familiar with it? Okay. So I'll go a quick overview and then give you a quick introduction. Go through what is serverless. And then I always like to include some Xamarin Forms examples because I want to kind of get rid of a misconception that Xamarin Forms is not for consumer facing and only enterprise. And I'll show you some applications that we've built and then some that are out there publicly. And I'll give you some links on how to learn more on specifically Xamarin. So very quickly about me. Started coding on a VIC-20. I've met a couple of famous tech people. There's one with Steve Wozniak, 3 kids. I like fast cars, and I am a certified used car salesman. So if you need a car, let me know. It's not my main job. My main job is Redbit, and I'm a 14-year Microsoft MVP, currently in the Visual Studio category. I'm a Xamarin University certified trainer. So if you need on-site training with your company, let me know and we'll connect you. It's the official Xamarin University training curriculum, but we do it on-site within 5 days. And through Redbit, we build various solutions. I've been lucky enough to work with a bunch of different companies, from startups to large companies like Microsoft. Our technology partners are Microsoft and Xamarin. We're still a premier consulting partner. I don't know what's happening with that. But enough about that. Let's get into Xamarin. So, just for some background, I mean, to develop mobile apps, there's a couple of different options you can use. You can use Swift, Objective-C, Java, Kotlin. There's also Xamarin, which we're going to be focusing on today. There's React Native, if you use React Native, and now there's Flutter. There's other things like Ionic. I don't use those, but Flutter seems to be the one that's getting a lot of press. I've read about it, haven't used it. I'm sticking with Xamarin for now. So far, so good. I've been doing it for about 6 years, and we'll go through everything there. So, Xamarin and Xamarin Forms. So there's two ways, this is a quick intro to Xamarin and what it is. So 2 ways to develop. So you got your traditional Xamarin approach, where you have your UI code, and you're building your UI specifically for the 3 different platforms. So you got your iOS, your Android, and your Windows. Then you have some shared C# code. So in this shared C# code, you're going to have accessing backend services. You're going to have all your models and everything. You're going to share that with the 3 different platforms that are there. With Xamarin Forms, you still have your native applications on iOS, Android, and Windows, but you notice that the layer is a little bit thinner on the UI side. So you're still going to have your shared C# code there, but what you're going to have is some shared UI code. So this shared UI code is essentially XAML, and this is where you can start sharing and building the same UI for the 3 different platforms. And the great thing is, and this is one of the big differences between, say, something like Kotlin and Xamarin. Xamarin uses the native controls and all the native SDKs, whereas Kotlin, as far as I know, it draws everything using Skia. So it's kind of like in the old Java days where they built all their controls, so it works on Windows and Linux and all that stuff. Seems to be the same. Everybody says Kotlin's amazing. I haven't tried it, and nobody on my team has tried it, so I can't confirm that. So what's included in Xamarin Forms? So you got 40 pages, 40 plus pages, layouts, and controls. So you're building your UI using XAML, or you could build your UI using code behind it. You have data binding. So if you're familiar with data binding and how to bind data to your UI and make your UI function, you have that built in. You have navigation that will work across the 3 different platforms, which is nice. So you can navigate from page to page within your mobile application. Animation APIs. You have some good functionality for animations within your application. You definitely want to take a look at those, especially if you're doing customer-facing, because sometimes or consumer-facing, because some of them there's small little transitions in there. You have this dependency service, dependency injection, things like that. If you want to do that, it's built into the platform. You can also use third-party ones. And there's a messaging center if you want to send messages back and forth, and I'll show you an example of that. So some of the main things are you have pages. So pages, you're going to have content, master detail page. These are a navigation page. So these are the different pages that you could have in your application. The main ones that I've used are master detail, navigation, and tab. So the tab one, you're going to have the tabs on iOS at the bottom. On Android, you can set it up, you could have it at the top or bottom. So those are, it's basically where you're going to put all your controls. And the controls are going to be within layouts. So here's how you want to lay out your controls within your pages. So you have things like absolute, grid view, scroll view. So different layouts that you could put on your controls. And these are the controls that you have within Xamarin Forms. So all these controls render the native controls on every platform. So on Windows, it'll render their controls. On iOS, it'll render those ones. And on Android, it'll render its own native controls. And that's one of the pieces that I like. So you could still customize these controls using XAML. And you can take it a step further by building what's called custom renderers if you need to build more functionality into your application. So here is an example of say a login page. So you notice how we have our tab pages. So we have our page component here, tab page, and then we have some children, and then we have content page right here, which has our layout. And that layout has two entries, which are basically text boxes, and they'll render over there. It has a button, and then we have our tabs that are rendered from our tab page right here. So you see the tabs here, here, and up here. You notice the button, we could put a background color. We probably want to do some styling. If you have a designer, they're going to definitely style your applications. So as a developer, we could go in there and do things, set different colors, and you could go further than that, not just set a color. And I'll show you some examples towards the end. So that is kind of a quick overview on Xamarin. We definitely can't cover everything on Xamarin. There's lots of content out there. Xamarin University is one of them, and it is free for some of the courses. But what we're going to build is a sample application, and I'm going to show you lots of code, so we're going to go through a lot of code. And it's going to be an iOS and Android app. We're going to build that quickly, and the functionality is going to be, we're going to take a picture, and we're going to upload it to blob storage on Azure, on the back end. So we're going to have two HTTP Azure functions. We're going to have a function that's going to be triggered on the queue. And then we're going to use Azure Storage, Table, Queue, and Blob Storage to make all this functional. So we're going to do this within, I think we have, what is it, an hour? And a half, maybe? Okay. I did it once. We should be able to do it again. So we'll do all that within an hour and a half. So this was all inspired by some real-life kind of problems that we've had. So in this, we wrote about it, so the technical articles here, kind of the whys are up on LinkedIn there. But essentially, we went through an issue where we built an application. It's called Upside, Tinder for Market Research. And we had an issue where customers were uploading images, and these images would be downloaded to devices. So we limited the size of the device to 2 meg upload. We didn't think users would use that entire 2 megs. So they would create these what's called blocks, and there would be 15 images within these blocks, and every image was 2 megs. So you got all these images being downloaded, so 2 megs, a lot over data connection, and then we were getting a lot of crashes on Android. So on Android, you have lower end devices with less memory and things like that. So we don't need the high resolution images. So we came up with this concept down here. You see at the bottom there. It's a little bit small. I'll have a bigger picture. But essentially, we have a REST API. They upload the image through the web, through the browser, and then we convert and create a bunch of other images so we can have different resolutions. Those images would be downloaded by the device. So if you're a low resolution device, you're going to download the low resolution image. If you're a high resolution, this Pixel, I don't know which version it is, that one will probably download the high resolution image. Still takes a lot of data, so we don't get away from that. But at least we stop the crashing, which is good. So it was inspired by that. That's available there. This is what we're going to be building today. So we got our Android application and our iPhone one. In the end, what we're going to do is we're going to have, here's our 2 triggers that I said in the summary. We're going to have table storage, storage queue. There's one other trigger that we're going to do so we can see what the state of the image processing is. And then we have our blob storage over here. So we have our original image that was taken, and then our different sizes that we want. So, like I said, there's lots of code.
Will these slides be available after?
Yeah, it's already up on LinkedIn. And then the source code's up on GitHub. There we go. So let me just set this up. Okay. So let me open this up. So when you first create, I'll just give a quick overview of when you first create a Xamarin application. So when you do File New, what you're going to have is you're going to have 3 projects. So on Windows, if you have the Windows UWP SDKs installed, it will create a Windows version for you too. I only have Android and iOS because I don't have those SDKs installed. So what it's going to do is create these 3 projects for you, your Android, your iOS, and we have another one here that's our shared code. So this is our UI code that is shared. Now from we'll open up the Android one. From the Android one, this is kind of that small little thin layer that I mentioned in the slide. This is the thin layer where we initialize Xamarin Forms. So here we init it, and then we call load application, and it's going to call our app.xaml up here. So this is a .NET Standard library right here, and these are referenced on both Android and iOS. So from there we create I'm creating a navigation page, and then within there I'm putting our main page, and we're setting the application.mainPage property to what we just created. Now in here, all we have is one button. So there's one button click, and this is just all kind of boilerplate code to make sure camera access is working. So I use a NuGet package called Cross Media. So this will allow us to access the camera both on iOS, Android, and Windows. All from within kind of the same main code base from here. So here we have our button clicked event. Here I am using code behind, because what I'm going to do is I'm going to kind of show you how you get up and running and then slowly start using view models and then moving code around into your functions and things like that. So here we have some code behind. All we're doing is initializing the camera, making sure we have a camera, and then taking a picture. And if we make it down here, we just display an alert. So I'm going to run this, and I'm using Visor. Just going to put it on Do Not Disturb. So once I click Run, I like running on real devices. I don't like using emulators just because it takes up more memory, and things just start going a little bit slower on this machine specifically. And this is a pretty good machine. So sometimes it does take a little bit of time when you do your first deploy. So this right now is compiling our Android application, and it's going to deploy eventually. There it goes. And you'll notice down here it's just signing it, zip aligning it, APK signer. So it's creating an actual APK and then pushing it up to the device. So here's our page, one big button. I'll just take an image, picture of the table, and then the picture was taken. So not very functional, but we're up and running. So now the first thing we want to do is we want to create our layout. So what I've defined here is a, zoom in a bit, is a grid layout. So we have a content page with a grid layout, and we just have some rows where we're going to have a status label, and we're going to have our image in the second row. That's going to take up the entire, pretty much most of the page, and then we're going to have a button at the bottom that's going to allow us to take that picture. We are going to use data binding, so you'll see here. We're going to use a view model to bind everything. So we're going to use the built-in data binding. And we're going to delete this method, because ideally you don't want any code behind, but sometimes you are going to have it. And I'm going to create or add some new code right here. So here we're going to create a main page view model, and we'll create this file soon. And then this is where I said we had the messaging center. So this messaging center, we could subscribe to a message, and we'll be sending the message from our view model base when we want to show display an alert. Now the reason we do this is because display alert is only available from the content page, from that base class. And this is just a kind of a generic way to display an alert on iOS, Android, and Windows. So I'm going to create a main page view model so our code can compile. So here we're going to have a few classes. So I'm going to just separate these out into different files. Like that. So let me do this again. To create a different class named view model base. Okay, so this one is our main one. So let me just separate these out into their separate classes. So this observable object and view model base is something that I've lifted from James Montemango's GitHub. So these are just some base view models, some base classes that we use for our view models, where we have things like title, subtitle, icon, if the view model is busy. So these we could data bind into our main page, or any page for that matter, and go from there. Here's the display alert that I mentioned. So we want to set a title and a message, and we want to say message sender.send, and that will be captured by this right here. So you notice we don't have a squiggly there. I don't know what the word is, but a compiled error. And then here we're going to do our main view model. So our main view model is inheriting from view model base, which I just showed. And we're going to have things in here such as a status. So if you remember, we bound it to here. And then we're also going to have our, just a Boolean to enable or disable the picture button. And then our main kind of command code and logic moving from our code behind into the view model is right here. So you notice we do almost similar things where we still initialize the camera, making sure it's available, and then we take a photo, and then as long as it's not null, we display the photo inside the application. So I'm going to start running this because it does take a little bit of time. Here, what we're going to do is, you notice how we're setting things like statuses. What we're doing is we're just grabbing the stream, so just a memory stream or a buffer, and then converting it to base64. And we'll be using this in the upcoming code that we'll create. So here I'm going to capture an image, picture of the bottle, Cool. So our image works. We got, you know, some nice view models and things like that. This is ideally how you want to structure your code, is with view models and trying to not put some code behind. And now, what we want to do is upload it to blob storage. So if you remember this image, so what we're going to do is we're going to go from the devices straight into blob storage at this point. And there's a reason why I'm doing this. And I'll show you how to kind of share your code across all the different platforms that are there. Because of C#, you can share it all across. And I'll show you how to do that. So let's in this and create a new project. And just say .NET Standard and Xam serverless.core. So core is going to contain all our core kind of libraries and functionality. And then from here, we're going to delete class 1. We're going to create a new class called Blob Manager. So Blob Manager is going to manage all the blob storage, how we upload and get everything in there. Let me just kind of go over this code. So we have our Blob Manager is up in Azure. So we're going to be using this one here. Xamarin Serverless Demo. So this is Azure. I'm assuming, how many haven't used Azure? Okay, you haven't. Okay. So Azure is basically where we're going to store everything. We are specifically using here table storage, blob storage, and queues. As you go in here, you will see different blob storage containers that we have, and we will create these automatically. So I've preset these up, I've copied the access keys over, and I've just pasted them in here, so then we could get things working. So we need to add this image, so we have this helper function, add original image. So if you remember, we want to add the original image that we take from the device, upload it up, and add it to blob storage. And this right here will do that. So we initialize a few things. So we get a storage account, blob container, blob client, initialize a few things, and then we upload. And this is where we're uploading the byte array that we're sending. So I'm going to add a couple of NuGet packages into all our projects here. I'm just going to accept. And now that's there, and our red squigglies should be all gone. So good. So then we need to update need to add a reference to the new core project. And click OK. And then our main page view model, we want to here, upload to blob storage. So here we're just going to set a status. We're going to call that helper method to add the original image, and then we're just going to display an alert. I'm going to send this up to my Android so we could test this. And while this deploys, a few tools that we're using is Azure Storage Explorer. This will allow us to kind of view everything in the blob containers that are there. You notice right now we don't have our original image containers. And we're also using Postman. This will be used when we use our serverless. Who hasn't used Postman? Okay, a few people. So Postman basically allows you to just make HTTP requests. The various requests that you have here, get, post, put, patch, all these things that you could do. So Postman is just a nice way to get that going. And we'll be using this once we do our functions. So now that that's deployed, I'm going to capture another image. Then it's going to upload. You see there it says uploading to server, and we're done uploading. And here we have a URL that it sends back. So that URL we could actually go out and download it. Here, if I go and refresh, we have our original image. And I'll double click that. Here's our image that we just took and uploaded. And that's the same image that we have up there. So kind of from our phone up to Blob, and then we could download it down. So now, if you notice, there's a few things in there. Ideally, and the reason I did this is because we all probably do this. You probably don't want things like this in your iOS or Android apps, because people can decompile, especially on Android. Even though it compiles down to native code, you could still get these strings. Somebody will have your connection string. Not a good idea. So we probably want to change that. But before we do that, let's kind of go over a little bit of some serverless and what it actually is. So that is very quickly building out a Xamarin application. So right now we are on this, remember, Android phone, iPhone, and pushing up to blob storage. So next piece we want to do is we want to create all these triggers and make everything kind of happen here. So the next few slides I kind of lifted from Laurent Bignon. So he's done a few presentations on these, and I figure why reinvent the wheel? So he's a cloud developer advocate. I think he works with you, Laurent? No?
He's
different
on
team?
the corp side, yeah.
Okay, he's a different team. But essentially, what is serverless? So this is the serverless and Azure functions. So there actually is a server, but you don't have any infrastructure headache. So as a developer, I think that's great, because I don't have to worry about infrastructure. I don't have to deploy web apps. We still do it, but I just want to kind of focus on our code, get things going out there. What I love, it scales on demand. It is very cheap to run, and I'll give you an example of this. So that application, the Upside, Tinder for Market Research, you can actually download it from the stores. You get free points. So Tinder for Market Research, swipe left or right if you like a product, right? It's not liking people or not liking people, but it's actually a product, and they use this for market research purposes. So once we deployed, it was great. They got a lot of users, very, very quickly, and our initial MVP code kind of slowed things down. So we had to scale up. It was built on Azure web app. We had to scale it up to a P3 instance. SQL Server, we also had to scale up to a very high tier. And the expected budget, when we first launched, the budget was like $250 a month, $250. Because we had to scale it up, we were looking at about $2,500 to $3,000 a month. So customer wasn't really happy. So within that month, we had to figure out how to make it faster. We decided to use a function to process all the data coming through. So what would happen is, as people would swipe, it would usually be between half a second to 5 seconds before a decision was made. So if they were getting 15 images or 15 products that they were shown, they were swiping quite a bit. So that was putting a huge load on the server. So we changed the architecture a bit where we would get all the data, push it on a queue, and then a function would be triggered to process that queue. Right? So you learn on the fly. MVP, you fix it as you run. Right? And the very cheap, so we got that fixed, got it all up and running. They were able to make their demo to a large customer in the US. And we were able to scale it back down, back to the $250 a month. I think we were on a standard S1. Scaled back down SQL Server, a few clicks, it's fantastic. And our functions, I think, are costing between 10 to 20 bucks a month, which is almost nothing. Compared to 2,500 to 3,000, it's a little bit easier to swallow. And the customer's happy. That'll always keep them happy. So, serverless architecture. So as you're building out your serverless and as you're playing around with Azure Functions, how many people have used Azure Functions? People. Okay. So what you want to do is you want to make them kind of isolated, small compute units. They're responsible for one thing, right? So in this example over here, they were responsible for processing the results and then passing it on to something else. So we did a lot of calculations, like how long people would take to decide on things, update the database, do all these things. We would make a bunch of functions, make them independent. What you want to do is you want to make them stateless, use queues or storage or anything, or table storage to manage that process. So then every function can be triggered at whatever state that you want it to be triggered. And that's essentially how you message between the functions. So table store or event grid, queues. There's many different triggers that you could do. You could even do GitHub webhooks, and I'll show you all the different ones that we could do. So these are all the different triggers that are available to run all your functionality. So now serverless APIs, these are your HTTP functions. So these are, you do a GET, you do a POST, anything like that on the HTTP level. And what's happening is people are building all their functions to one endpoint. So if you built web applications, ASP.NET Web APIs, what you'll have is you'll have a controller, and then you'll have a bunch of different methods in there. So what you're doing is you're taking all these methods and putting them at the function level. And then you don't have to worry about the entire, ASP.NET Web API or web application and all that stuff. You just build your function and away you go. You can secure the functions. You can use SSL. You can provide authentication. I don't know about this architecture, about this, one endpoint or one function for every endpoint. We haven't done that yet, but I'm seeing kind of a lot of people doing that. I don't know if that's the best way. I kind of still want our web APIs, and you could automate. So when you use functions, you might lose a little bit of control. If you want control, you probably want to stick with web APIs if you're doing HTTP functions. But we'll be building a couple of these. So we'll be building 2 HTTP triggered functions and one function that is triggered on a storage queue, and then to do all the processing and throw everything in blob storage. Okay. So let's go back. So now the next step is we're going to start building our Azure functions. So let me pin this. So now here, I'm going to add a new project. Call it the functions. So I'm going to click OK, and then it's going to give you a couple of options here. So on this dialog, you have your V1, your .NET Framework, and you also have your V2 for .NET Core. V2 is still in preview, so I haven't touched it yet. I've played around with it, but haven't done it in production. So we're going to pick a V1, and you notice how we have it has a few here. Once we add a different one, it has a different dialog that shows you many more triggers. But these are the triggers that I was mentioning. So you have your HTTP trigger, your queue trigger, and your timer trigger. So we're going to pick a HTTP trigger. I'm also going to set this up so it connects to that storage there. And I'm just going to create a function here. I'm going to change the function name to image upload function. I'm going to say no, and I'm going to change the name there. This is what your endpoint is going to be. So it's going to be your http.whatever.com/API/function name. So this is where it's going to be, and this is where you could set the get, the post, and all that stuff. Let me just put it down here. So that's where you could set it. So I'm going to just run this. I'm going to set this as my startup project. And I'm going to hit play. And I'm going to say no. So this is something that I ran into today as I was running through my demos. For some reason, the latest version gives this error. So to fix that, we need to downgrade. And this is straight out of the box. I don't know why. We need to change our NuGet package for functions from 1.0.13 to 1.0.11. Don't ask why. I will research it later. If you're interested, email me and I'll tell you why. I have no idea why. So now, it's not exactly fun when you find out 2 hours before your presentation that things are broken. Okay, so now we got no red text, so everything's running, up and running. You see our function right here, upload image function, localhost, that's the port it's on, 7071, API image upload function. So, another tool I'm using is called ngrok. Ngrok allows us to have a public-facing URL and redirect back into our function. So here, right here, you see I have this is our public URL that I'm going to be using, and it's redirecting to localhost 7071. And here you see some testing that I've been doing, making sure things are working. The reason why we use ngrok, because if you try to access localhost from here, it's not going to work, because localhost on here is actually this device. It's not going to talk to your Azure function. So you want to, that's one way to kind of get around that without having to deploy out to Azure or something. Now we're going to look at Postman. So Postman is going to do a get or it's going to do a post, or we could do a get or a post because that's what we've defined here. But essentially what we're doing here, this is kind of out of the box. We're just going to grab the name, and then we're just going to respond with a hello and the person's name. If you don't pass in a name, we're just going to send in a bad request. And here you notice it's just a HTTP response message that we're sending back. And if you've done web APIs, it's very similar, where you do the request, which comes in on your parameters. Try that again. Here's your HTTP request message. So this is the request that's coming in. And then you're giving it some responses. So either a bad request or an OK status code. So you could debug these functions just like you can in any Visual Studio project. Here I'm using the query string to set the name right there. So I'll change that to that. It's going to send it in. There you see our function got triggered. So you see a little bit of text there. Our breakpoint hit. We could step through, and there's our query string that we sent in, the mark 444. So I'm just going to run this back into Postman, and we have our response. You could also send using the body and this Postman thing. For those who haven't used it, you could send it in. It'll still do the same thing. But instead of looking at the query string, it's going to look at the body in here. And it should send back right here the hello mark. So there is our first function. So now what we want to do is we want to update it to actually accept an image. So I'm just going to replace this with demo3 right here. So it's very similar to what we had before, but instead of looking for a name, we're looking for this right here. So we want to make sure we have a body. So we're doing a post because we're going to send a base64 string up. And then we want to send a bad request if there is no body found. If we don't have this, this property in there, image b64, then we want to respond accordingly. And then we want to convert that base64 to a buffer and send that back. So we could actually throw a breakpoint in here, run that. I don't know why I keep saying this, but. So here's an sample that I have for upload image function. And there's the base64. So this is actual image that I converted and captured and threw it in here. So if we send that up, you notice that we have our image data right there. So there's our base64 string and converted to a byte array. And you'll see it is about 0.5 meg in size. So for now, we're just sending a response. Everything's okay. And you notice that this has the appropriate kind of text in there. So now next step is we want to save it to blob storage because we don't want our devices sending it directly. So I'm going to manage NuGet packages. So I'm going to remove our Windows Azure storage from our mobile apps. And then I'm going to add it to our functions. But what I'm also going to do is I'm going to downgrade it to 8.7 because the SDK for Azure Functions is only up to 9 for JSON.NET, if you see right there. And Azure Functions, if you use the latest one, it'll try to use 10. So you're going to get a conflict in there. So only 8.7 will work. And that was after a lot of hours of what the hell's going on. So I'm going to install that on our core and our functions. And let that run. And what was that? And then look at my cheat sheets. And that's done. So our image upload function, we now want to replace this piece. 2, right here. So if we have, if the length is 0 of the buffer, we just want to send a band request. We can't do it. And then we want to have our, we want to use the original core manager, if you remember blob manager. So we need to add a reference to that. And here, right here, you see we're sharing C# code on the 3 different platforms, on mobile, iOS, Android, and on, where's core? There it is. We're sharing this exact same code, we're sharing within our Azure functions. So we can run this. And there's our function. I'm going to upload, make sure this runs. Good to go. And send that up. There's our URL that we got back. And if you remember on the mobile app, we got our URL. There's our image that we downloaded. And that's the image that I took when I was testing. See my little Buddha guide there. And then we also have that same image. It actually goes into blob storage here. And this is the exact same image. So we're kind of getting there, getting our application going.
Do you deal with errors? What if the upload doesn't work?
The output doesn't work where?
You upload the image to the blob storage, yeah?
Yep.
What does that one fails? Normally you get a URL, yeah?
Yeah, then throw a try catch in here if there's an error uploading. But right now, if you upload and if any of this errors out, right here. So what will probably error out is this. If you lose a connection while it's trying to upload, then you're not going to get the URL back.
But there are situations where, let's say, it uploads. Can you get an error back from the blob storage or something?
Yes, you could get different HTTP status code errors. I can't remember what they are, but you can get different errors. Table storage will also give you different errors if you're trying to insert a record and then there's a conflict with the partition key and the row key. So there's different errors that you can get back. Here, if there's an error, what will happen, so if there's a runtime error, it will return at 500 HTTP status code, which is internal server error. So that's what will happen there. You could put a try catch there if you want, and then catch that and then send a bad request or something. But you could probably just leave it and just leave 500 internal server error and then go out and rush and figure out what happened once your app blows up. So, all right. So we're sending to blob storage. Next thing we want to do is we want to make this work from our Android app. So I'm going to set this one as startup. And then go into our main page view model. Minimize that. And I think we're on step 3. So here we have a helper function that's just going to upload the image. So essentially the same thing that we did with Postman, we're just going to do in code right now. So I'm just going to add a few using statements. And I'm going to need 2 new files where we have upload payload. So this is our payload that we're sending up, and we're going to have a response payload. So I'm going to throw these up in core. And I'm going to replace with out. And this is just more of my preference. You could leave it in there, but I just like separating them out into different files. So now we have our upload payload and our upload response. And now our squigglies are gone. So I will set this and deploy to my pixel. And then once that's done, I will do this right here. Start our Xamarin serverless function. So I'll show you the error, the 500 error, because we're going to get one. It's part of my demo. Actually, no, I didn't do something here. So here we need to get rid of this. I don't want to cancel the build because things will go south. And then let's step 4. Missed it. Okay, so turn on device, but I need to call our helper function here. So that's going to kind of stop uploading straight to blob storage and use our new function. And you notice I have the ngrok URL right here and our upload image function. So it started on the device, so I'm going to start this function. Debug, start new instance. Wait till that starts, go capture an image. Sure, my water bottle, click OK. See our status, uploading to server. We got it in here, but we got a bad request. All right, so something happened in here. And what happened was, in our function, so if you remember in here, we have some kind of strongly typed classes or objects now, upload payload and upload response. But our function is expecting something else. It's using dynamic objects. I'm not a fan of dynamic objects because we ran into this a lot of times. So now we have a policy where you make a class, or else you're fired. It kills you when you're trying to figure out, okay, why isn't this working? So demo. See, I told you I'll be open. I fired people. It's not fun. But Mark says, don't use dynamics or you're fired. That's not it. See, now I'm confused. I shouldn't say jokes. Okay. So this is still our upload image function, but what I've done is I've used the upload payload right here, just deserializing the object. But you notice we're still using the same code on server side and the mobile side. And this is the piece that I love about Xamarin, because you could do that. And then here we're sending an upload response with the URL that we want to send back. I got the application running on my Xamarin or on my Pixel, so I'm just going to set this as a startup. And here. Capture another image, do that. Cross your fingers, hope it works. There we go, we get our URL. We go into our storage, we get another image here. And there's the picture that we just took. No, wrong one. What time is it? It should be done, right? 23, no, 31. There you go. Cool. So now, if you remember, we are going from here into here, and from both applications, we're now sending through the HTTP function into blob storage, sharing code across, and now we get to build all of this over here. And It's 7:30. Does anybody want a break? Yeah? Yeah, this is usually, the break time. Because then we just kind of run through all this stuff. Cool? 5 minutes? 10 minutes? I'll take questions, if you want.